Hey guys, welcome back to the Timber Forge, and in today's Let's Code video, I'm going to be showing you how to create this throwable fireball from Hypixel's bedwars. Alright, so as always, I'm first going to show you what I have to start with. So of course I have the custom model because what I'm actually using is a snowball. It's not actually a fire charge because using villager right clicks for a moving player is not really good. So I'd rather just use a snowball since it's simpler. So right now I have a resource pack where when I give myself a snowball that has custom model data on it, and make sure you go check out my custom model data video if you don't know how to create custom models for your items. But when I give it a custom model data, then I get myself a snowball which looks like a fire charge. And right now it doesn't really do anything, but I'm going to be using this in order to detect when the player throws the custom fireball. And I also set up a basic data pack. So there's nothing actually in here right now, but just to show that this is the data pack that's loaded when I do say hi. And if I reload, you'll notice that it says hi. There you go. So that's what I'm starting with, a basic resource pack and data pack. The first thing I'm going to start off with is creating the actual custom item. I'm not going to start off with a custom recipe or anything like that, since I have tutorials on how to do that, and it's basically just following the tutorial and there's not too much interesting about it. So I'm going to start off with the actual item itself. And on MC Stacker, I'm just going to create a give command for a snowball that has all the data that I want. So first of all, I'm just going to select all players. And I'm going to be putting this in my load function. Actually, I'm going to be creating a new function as a give function to give myself the actual item. So the item, of course, is a snowball because that's how we're going to be detecting the right click. And the name I'm going to be setting to fireball since I want it to basically look exactly like the fireball in bedwars. And I don't want it to be italic because by default it's italic, and I'm going to make sure that it's white. And then the important part is custom model data. So I'm using a value of 3473 because that's what I set in my resource pack. And for custom tags, I'm going to be using one called Fireball 1B. You can name this whatever you want when you're detecting your custom snowballs. I did basically a similar thing in my throwable water video if you guys want to go check that out. I'm basically just giving myself a detectable snowball. Now I'm inside of VS Code, which is the text editor that I chose to use. So I'm going to create a new function called give.mcfunction. And I'm just going to paste my command right inside of there, and then Alt-Z wraps the text so that it collapses and doesn't just go off. And that should be good. So if I go back to Minecraft, and then I run that function, and then fireball give, you'll notice that I have a fireball, which is actually a snowball, has the proper name, and as you can see it says NBT 3 tags as opposed to this one which just has 1 tag on it. So that means that the custom tags are actually added properly. So now that I have the actual snowball to detect, I have to actually do the detection. And in order to do that, what I'm going to do is detect this fireball 1B NBT tag. And inside of loop, I'm going to create an execute command. So I'm going to execute as all entities because I'm trying to detect the entity which is a snowball. And then of course type equals snowball because that is what I'm trying to detect. And then I'm going to detect the NBT. And if you ever are trying to detect NBT but you don't know the syntax, just use the data get command. So far this is still pretty similar to what I did in my throwable water video. So data get entity and then at E, and then I'm just doing type equals snowball limit equals 1. So when I run this while the snowball's in the air, you'll notice I get all of the data. And what I'm trying to look for is the fireball tag because that's all I'm trying to detect. And as you can see, it's right over here, fireball 1B. Now, before I could just stick this in, I have to see what it's within. So I could see another pair of parentheses here. It says tag. So I have to do tag colon and then do a double bracket and then fireball. And that is within item. So I have to do item and then tag and then fireball. So now if I go into here, inside of NBT, what I have to do is first item and then 2 brackets and then tag and then Alt-Z to wrap. And then inside of there, then I can do my fireball 1B. And just to make sure it's working, I'm going to do run say hi. So when I throw it, it should spam hi until it's gone. And as you can see, it works. So now that we know the fireball detection works, what we could do is actually run it onto the player and run a new throw function. So first, to make sure that it actually runs at the player's eye level, because that's where we want it to run out of so it's easier for the player to aim, what I'm going to do is I'm going to actually run it as the nearest player to the snowball. And since it's going to detect it immediately, then the nearest player is going to be whoever threw the snowball. So as the nearest player, and then at S, so it actually goes to the position of the player, And then I'm going to do anchored eyes to make sure that it actually goes to the eyes of the player. And then run function, and then a fireball. And I'm going to create a new function called throw for the actual summoning of the fireball. So now I'm going to go into here and create a new file called throw.mc function. And just for now, I'm going to do set block stone. And you always want to do small tests like this so that you know everything is working. So now that that's done, I'm going to go test it, reload, and it should just spam stone. There you go. As you can see, it just places stone onto me. So inside of the throw function, what I want to do is kill off that snowball. So I'm going to delete that stone that was temporary for the detection, and I can add the things that I need. So first of all, I want to kill that snowball. So since I already have the data detection here, I could just steal this, and I'm going to stick it right in here. And I'm going to add a kill command. So kill, and then I want to do just this nearest one. I don't want to kill all of them. Sort equals nearest, limit equals 1. So it should kill off the snowball, because remember, I can't do kill at S because this is running off of the player's location and as the player. So as at player. And then also I want to summon the fireball. So summon fireball, and then at this position. And right now I'm just going to leave that blank. I'm not going to set any other data, but I'm going to set that later. So now when I reload, it should just place the fireball at my position. And actually something you'll notice is that it's not actually placing at my eye level, it's placing at my position. And I think I forgot to put something in, but this is actually kind of important and you might forget. Yeah, so I forgot to put vector coordinates here, and when you're using the anchored eyes, you need to use vector coordinates as opposed to like relative cardinal coordinates. So use these upward caret thingies, and it should actually summon it at my eyes now. Let's test it again. Oh, yep, and as you can see, it's summoned at my eye level. I couldn't actually see it because it was inside of my eyes. If I go F5, you'll notice it goes exactly at eye level, which is perfect. And also, I'm just going to put in some play sound commands here. You guys don't need to watch me create play sound commands. If you want more details about the play sound commands, I actually have a video on that, but there's not too much to it, so I'm skipping over it right now. So now I'm going to add some data to the fireball because I want to actually give it motion, and in order to give it motion, I first have to be able to detect that it exists. So in order to do that, always use an entity tag. So I'm going to add some NBT here. So tags : 2 square brackets, and then quotation marks, and I'm just going to call it player just to label the fireball to indicate to my commands that this was thrown by a player and isn't a fireball from a ghast. And I also want to change the explosion power because, as you noticed earlier, it didn't actually do any damage to the stone. So I want to up the explosion power to 2. I could always change it later on. So with that, I could actually detect the fireball now. So the original concept for this motion system is from Nope Name. He's on YouTube. So make sure you go down in the description below and check that video out before you watch this. But it's not really a tutorial, so if you guys do want me to create a tutorial on turning rotation into motion, then let me know in the comments down below. The way that this works is that the first thing you do is you get the first position of the entity, and then you use a short teleportation just to give it the direction that you want, which you could do if you use the rotation combined with a vector teleportation. So if I just do like /tp at s, and then I do vector coordinates, and then I go like 1 block forwards, then it'll teleport me to second position in the direction that I want to go. So that means I could get the first position, of course, and then the second position based on which direction I want to go. So once I have those two positions, I store those into a scoreboard, and then what I do is I subtract the first position from the second one. When you have a fireball, what you do is you summon the fireball at this position. So let's say I throw it right here, so it's going to be here. And then I teleport it in that direction a little bit, so now it's here, for example. And then what I do is I subtract the first from the second, just like in that example, and I send it in that direction by applying that difference into its motion. Alrighty, so now let's get to applying that motion to the actual fireball. There's actually not too many commands, but first of all, I'm just going to make sure that the fireball summons a little bit in front of the player, not directly inside of his face. So now I'm going to create a new function which is going to run on all of those fireballs, and I'm just going to call it motion because that's what we're going to be doing. We're going to be applying motion to that fireball. So I'm just going to call it motion.mc function. And now we actually have to run that motion function. So inside of the loop MC function file, I'm going to create a new command which will run onto those fireballs. So execute as all entities and then type equals fireball, because that's what we're trying to detect. And then I want to add the tag detection, because remember we summoned the fireball with the tag of player, and the reason we do that is so we could detect it now. So tag equals player. And we also want to create a detection to make sure that we only apply motion once and we don't do it constantly, because there's no point of doing that. So I'm just going to create a new tag. So I'm just going to say like tag equals not motion. So exclamation mark means it has to not have this tag. And once we run the motion function, I'm going to add that tag so that it only runs once. So it's going to run as those fireballs, and then also it's going to go at those position of those fireballs. So at s, and then rotated, and then as the nearest player, because remember we want it to go exactly where the player is facing. And then I'm going to do run function fireball motion. And this thing is being annoying. And if you remember from the example, what we need is the first position of the fireball, the second position of the fireball, and then we subtract the first from the second, which means we don't need a new scoreboard for that, so we're just continuing to use the second scoreboard, and then we apply that to the motion. So that means we need two scoreboards. We need to create one scoreboard set for the first position and one scoreboard set for the second. So I'm going to do that in load.mc function, and I'm just going to create new scoreboard. So I'm just going to do scoreboard objectives add, and I'm just going to call it fireball. So I'm just going to say like FB, and then I'm just going to do X1, and then I'm just going to make it a dummy because we're going to be storing the data ourselves. So I'm going to take this, and then we're going to do it for the X, the Y, and the Z. So I'm going to copy this, and we also want to swap this so that we have two sets. We have the first set and the second set for the first position and the second position. And now in order to actually store these data values, the first thing we want to do is get the initial position, which is very easy. So let's go to our motion function, which is going to run on all of those fireballs, and we have to do an execute store command. So first as at fireball, and execute store basically takes data from one place and puts it in another place. So here's how we're going to store the data from the position into a scoreboard. So we do execute and then store and then the result, because that's what we're trying to get. And the place that we're trying to store it into is a scoreboard, so I choose score. And then whose score, since I'm going to be running this command from the fireball, I do score at s. And then the scoreboard I want to store it into is for x1, and we'll repeat this for all of the other ones. So x1, and then the way that this works is that it stores the result of this command. And in order to get the result to be equal to the position, what I do is I run data get, and then for the entity of at s, since it's the fireball that we're trying to get the position of, and then the data we're trying to get, we have to select the path, and that's going to be POS 0 for position 0. And that's just part of the NBT data. So if I get the data here, you'll notice that it has POS for position, and it has X, Y, and Z. And since it's a list with square brackets, that means in order to select the first part, you do position and just put 0 in the bracket. So that's what the 0 in position 0 means. It just means the first item of the list since it's 0 indexed. So now I'm back in VS Code, and I'm just going to paste that in here and delete the slash. And I'm going to repeat this for X, Y, and Z. So X, Y, and Z, and I get position 0 for X, position 1 for Y, and position 2 for Z. Now if I go back into Minecraft and I reload, you'll notice that if I scoreboard set objective set display sidebar and then FBX1, then you'll notice that FBX1 for this actually gets set to a number. And as you might notice, it says 219 here, and it only stores integers. And in order to get around that, to maintain accuracy, what you have to do is multiply it by a number. And in order to do that, it's just built in. All you have to do is add a number to the end of it. So I'm just going to add like 1,000,000 just to make sure that I maintain accuracy, because scoreboards only store integers, and you want to make sure that the motion of the fireball stays accurate. So I'm just going to multiply it by 1,000,000. You'll notice that the number is now a lot larger because we got the number for the coordinates and then multiplied it by 1,000,000. And when we want to put it back, we're just going to divide it down so that it becomes a smaller number and it doesn't go flying instantly fast. So now let's get the second set of positions now that we have the first one. And all we have to do is teleport it forwards and then copy this again. So since we're running as at the fireball and rotated as a player, I could just do TP at S and then, whoops, and then I'll go 0.1 blocks forwards. And now we're going to be in a new position in the direction that we want. So I could just copy this over. And now instead of storing it into the X1, Y1, and Z1, we do X2, Y2, and Z2. So now we have two different coordinates. So now let's go back to Java. So now if I throw this, oh, now you'll notice it goes on forever because I forgot to add the tag. So let me add the tag, because remember we're supposed to run motion and then add the tag for motion so that it only runs once. So tag at S add motion. Now let's do it again. So as you'll see, X1, so you'll see it ends with 6015. So now if I set it to X2, you'll notice it's a different number. Now that we have those two numbers, we could subtract the first one from the second one in order to get our motion. And now in order to do subtraction, if you don't know, there's something called scoreboard players operation. So I'm going to show you this. It's called scoreboard players operation, and you basically have to choose two different scores. You choose the first score, which is what you're going to be storing the information into, and the second one, which you're going to be using as a tool to manipulate the first one's data. So I'm going to do scoreboard players operation, and the first one I'm going to do is the scoreboard for FBX1, or no, X2, because we're subtracting the first set of coordinates from the second set of coordinates. So I'm going to start off with the second set of coordinates, and then I do minus equals. As you'll see, there's a bunch of options here, and the one we want is minus equals. And then we're going to do at S, and then FB underscore X1. So this is going to subtract the first one from the second one and set the second one's value to the result of that operation. So I'm going to copy this, and I'll paste it right after we get the second position. So if I put this here, and now I just want to make sure that I do X2, X1, and then Y2, Y1, and Z2, Z1. There we go. So now if I test it, you should notice that the number gets a lot smaller. So if I throw this, you'll notice X2, the number is a lot smaller than it was before. So if I show you X2, and then compare that to X1, which is the actual coordinate, because X2 is no longer a coordinate, it's now our motion vector. Now that we got our motion, what we could do is store it back into the fireball. And let me just summon it for example here. And if I get the data, you'll notice that there's this part here that says motion. And this motion is where we're going to be storing our information that we just got, which is our new motion vector. In the same way that we got the position NBT data from the fireball and stored it into the scoreboard, we're now going to do the opposite. We're going to take the scoreboard info for X2, Y2, and Z2 and store it into motion 0, motion 1, and motion 2 of the fireball. So in order to do that, this is how the command is going to work. So it's going to be execute, and then we're going to do store again, and then result. And this time, instead of storing it into a scoreboard, we're storing it into an entity. And then at S, since we're going to be running this from the fireball, and where we're storing it is going to be in motion and in the first value, since I'm starting with X. And then and then you need a data type, and in this case it's double, and you could tell since all the motion values have a little d after it, so it says like 0.0d. And then this is where you put your this is where you put the number that you're going to multiply it by. And so I'm just going to put like a small number here, and then I'm just going to adjust it based on what I see. And then run scoreboard players get at S, and the score we're trying to retrieve is FB underscore X2, because that is our new motion that we're trying to get. So in summary, we're taking the X2 scoreboard value and storing it into motion 0 and making sure to multiply it down. So let me take this and paste it into VS Code. And I want to make sure that I do this with X, Y, and Z, and also make sure to store it into the correct slots of motion. So motion 0, motion 1, and motion 2, and then X2, Y2, and Z2. Now if I go back, reload, what you'll notice is that when I throw it, it now has motion, but you'll notice something else. When I throw this, it starts off fast, but then it slows down. And I actually didn't know what was causing this, but there's actually another part to fireballs. and they have acceleration, and if you don't add the acceleration, then they actually slow down. So if I get the data, you'll notice that there's a part that says motion, and that's what we were manipulating earlier, but there's also another part called power, and right now it's 0, 0, and 0. And that actually determines the acceleration, apparently, that goes on the fireball, and you actually have to add that so that it doesn't slow down. But it's super simple. All you have to do is copy the stuff that you did for motion and put it for power. So now motion I'm going to replace with power, and it's a lowercase p. So power and power. And I'm also going to make it a smaller number, so I'm just going to add an extra 0 here, and I'll tweak it if I need to. So now if I reload and I throw it, as you can see, it goes, that was a bit too fast. I'm actually going to decrease it a little bit more. But I'm just going to keep tweaking all of the numbers. So that seems about what the Bedwars fireball travels at. So that's basically all we have for our fireball.